In section 10.2, we need to know sine, cos and tan of certain angles. Now we know sine, cos and tan of any multiple of 90 just by looking at the graphs. If you look at the graphs, something interesting happens every multiple of 90. So let's take the sine graph as an example. Sine graph starts at 0, and then we go like this. So sine of 0 is 0, sine of 90 is 1, sine of 180 is 0, sine of 270 is -1, sine of 360 is 0, and so on. So we know the sine, the cos and the tan of any multiple of 90 degrees. We also need to know about 30, 45 and 60 degrees. And the reason we need to know those ones is because there is a neat trick for finding them. And the neat trick is two triangles. And here is the first one. This is an equilateral triangle, so this is going to be 60 degrees. And I'm going to make the lengths all length 2 units. So if I then put a perpendicular line down the middle, a line that's perpendicular to the base, straight down the middle, a line of symmetry down the middle, this length here would be 1 from here to here. And let's just draw this part of the triangle out again then, just the bit that we need. This is our 60 degrees there, 30 degrees here. So this is our 30, 60, 90 triangle. That's 1 and that's 2. Now by Pythagoras' theorem, I can find this missing side, and check me if you want, but it turns out to be √3. So this will tell us that sine, cos, tan of 30 degrees. Sine of 30 is 1/2, cos of 30 is √3 divided by 2, and tan of 30 is 1 over √3, which we can write as √3 over 3 if we rationalise the denominator. And it will also tell us sine, cos and tan of 60, and I'm just using here SOHCAHTOA, right? So sine of 30 is 1/2 because it's opposite over adjacent. Cos of 30 is adjacent. What did I say? Sine of 30 is 1/2 because it's opposite over hypotenuse. Sine of 30 is adjacent over hypotenuse. Tan of 30 is opposite over adjacent. So 1 over √3, which rationalises, when you rationalise the denominator, you get √3 over 3. Sine of 60 is √3 over 2. Cos of 60 is 1/2. Tan of 60 is √3 over 1, so √3. So we get sine, cos and tan of 30 and 60. And then the other triangle that we want to be able to deal with is this one. It's an isosceles right-angled triangle. So these two sides are the same length. So that will mean, if you think about it, that this is going to be 45 degrees. By Pythagoras' theorem, this triangle will have √2 as its hypotenuse. And so that tells us tan of 45 degrees is 1 divided by 1, so that is 1. Sine of 45 degrees is the same as cos of 45 degrees, and they're both 1 over √2, which when we rationalise the denominator is √2 over 2. Okay, so we know all of those ones. You need to be able to get to those really fast. So if I say what is sine of 60 degrees, within 10 seconds you need to be able to work it out. By the second year of A-level, you need to be able to do it within, say, 5 seconds. So if you can memorise these, brilliant. If you can't memorise them, you need to be able to get there quickly. You can sketch this triangle quite fast. Okay, it doesn't take very long. Even if I cover this up, I kind of go, okay, it's a 30, 60, 90 triangle. So 30, 60, 90 degrees there. That's 1, 2, and √3. So I can sketch it fast. And if you can scribble it out like that easily, with a bit of practice and recall, you'd be able to, then you can work out the sine and cos and tan of 30 and 60 quite quickly. You need to be able to do those. We use them an awful lot at A-level. So one way of getting these is to remember these particular triangles and get there that way. Somebody's just shown me another trick, which I can't believe I've never seen before, but it goes like this. 0 over √2. No it isn't. It's √0 over 2. It's √1 over 2. It's √2 over 2. It's √3 over 2. And √4 over 2. So sine of 0 degrees is √0 over 2, because sine of 0 degrees is 0. Sine of 30 degrees is √1 over 2, because √1 is 1, so it's 1/2. Sine of 60 degrees is, sorry. Next interesting angle is 45 degrees. Sine of 45 degrees is root 2 over 2. Sine of 60 degrees is root 3 over 2. And sine 90 degrees is root 4 over 2, because root 4 is 2, and that is 2 divided by 2, which is 1. Okay? So 0, 30, 45, 60, 90, root 0 over 2, root 1 over 2, root 2 over 2, root 3 over 2, root 4 over 2. And then cosine goes in reverse. So this is cos 90, cos 60, cos 30. Sorry, keep missing out 45, don't I? 45 degrees, cos 30 degrees, and cos of 0 degrees. Okay? So those are... there's another way. If your sort of brain works in a way that is more memorable than the triangles, then that's helpful for you, I hope. When we get to exercise 10b, they're asking us to find exact values. I'll do an example with a cos in this time, because I've done a couple of examples with sine in. So I want the exact value for cos of 300, and that works like this. There's my cos graph. Starts at 0, goes up to 360, because the number I'm looking at is 300, so I don't need to draw it any bigger. 300 and, cos of 300. So that is 60 degrees away from 360. And that's 30 degrees away from 270. Okay? If I use the fact that this shape here is exactly the same as this shape here, 30 degrees away from where I hit the x-axis, 60 degrees away from the top of the this sort of lump here. So that is 60 degrees. So the cos of 60 degrees is this number here. That's the same as the cos of 300 degrees. I don't have to worry about putting a minus sign in front of it, because they're both positive. So cos of 300 degrees is the same as cos 60 degrees, and cos 60 degrees, I remember, is a half. And if you don't remember that it's a half, then you need to use this trick or draw the triangles out. So finding the exact values, it's the same as exercise 10a, but we need to actually find an answer rather than just saying cos of 300 is equal to cos of 60. So you'll see that all of those in exercise 10b are either 30, 45 or 60 degrees away from a multiple of 90, unless they're being particularly sneaky, in which case one of them will actually be a multiple of 90, and the answer is just going to be 0 or 1 or -1. So that is section 10.2.